Hello dear learners, this is Dr. Sedhupathy, Assistant Professor, Department of Computer Science with Artificial Intelligence and Data Science, Dr. SNS Rajalakshmi College of Arts and Science, Coimbatore. So today's discussion will be like operating system structure. It is one of the essential thing comes under basics of operating system. So today's agenda for discussion will be like operating system structure, what it is actually, and base of a system structure, and memory layout for multi-programmed system. So what actually operating system structure is, basically operating system provides a type of environment inside that application programs are executed. The application programs may be related to hardware components, or may be related to user views, or may be related to remote views. One of the most important and high prioritized aspects of operating system is the ability to do multi-programming. If an operating system does only one task or only one program at a time, means so computer concepts will not grow this much. Nowadays technologies are growing ever fast, as we never expect the computer field will grow like this, like in the current scenario. So for that, multi-programming is one of the core aspects inside the operating system structure. Okay, let us check what are all the things comes under multi-programming structure. Multi-programming, sometimes called batch system also. It actually essential, it actually required for this current technology growing trend for specifically efficiency. For a single user, we cannot keep CPU and input-output devices busy at all times. If it means the hardware utilization is very poor, also user also need to wait for a single input-output devices busy at all the way from the beginning to end of the process or task. So multi-programming, which organizes jobs, here jobs in the sense each job or task contains set of code and set of instruction and a set of data which are needs for the type of instruction. So CPU always has one to execute, at least one task to execute always. CPU cannot hold all the IO devices together for a long time by saying busy at all the way. So a subset of total jobs in system is kept in a memory, and the tasks are requested or taken into the process one by one simultaneously. In general, main memory is too small to accommodate all the tasks. So the tasks are stored in the secondary memory, and simultaneously the tasks are retrieved from secondary memory to the main memory one by one. The jobs are kept initially on a disk in the job pool. Actually, continuously fetching all the jobs one by one or simultaneously is the concept called the job pool. The pool consists of all the processes residing on a disk awaiting allocation of main memory, which means the pool of processes are stored in the secondary memory, waiting in a queue and awaiting for the allocation from the main memory to get some space in the main memory. This can be achieved by job scheduling running. For one job selected to run, it actually happened by job scheduling access. When it has to wait, For example, it has to wait for an input-output operation. The operating system switches to another operation since the previous task is waiting for some other input-output operation. So operating system does not wait for that particular task which is actually waiting for some other input-output operation. So basically it switches to another job, and CPU can able to achieve another job while waiting for the input-output operation of the earlier task. So this is something, one of the beautiful thing in the multiprogramming concept, no? And here is the further continuation how multiprogramming structure is happened. Multiprogrammed system provide an environment in which the various resources are utilized effectively by means of no resource is weighted or no resource allocation is weighted by simply in a queue. Here, multitasking or also called time sharing is logically extension in which central processing unit switches jobs so that frequently that users can interact with each job it running all the way, creating interactive computing environment. Here the response time is very low, basically less than 1 second for the response, and each user has at least one program for executing in the main memory, at least one task or one process. If a person or user has several jobs ready to run at the same time, CPU goes for the scheduling process, which executes the task one by one. All the tasks are stored in the secondary memory, and the pooling contain all the jobs in a queue. If the process doesn't or don't fit in the memory, swapping happened. The process taken into the second memory, another job is swapped from the second memory to the main memory. It moves in and out to run. So this kind of swapping happens. In this scenario, virtual memory comes, which is a concept allows the execution of process not completely in memory. When the process cannot able to fit into the main memory, virtual memory can able to achieve the completion of the process. Here the memory layout for multi-programmed system. At the top of the diagram, operating system, and in the job pool there are stack of jobs, namely job 1, 2, 3 and 4. Operating system takes one by one and executes in a multi-parallel way. This is actually called multi-programming system structure. Thank you learners for your patient listening. So I would like to look forward you all in the upcoming videos with some other topic. Thank you once again.